Hello, this is Mr. Collier, and today we're doing expansion and factorization with indices, otherwise known as exponents. Okay, so we're going to do one example from each page, probably. Um, let's do this one down here. Okay, so this is all squared, so you're going to have to do 7 to the power of x plus 7 to the power of negative x times itself. And we're going to get four terms, 7 to the power of x times 7 to the power of x. You can write it a couple different ways. You can write it as 49 to the power of x, or you can write it as 7 to the power of 2x, for instance. Actually, you can write it as 7 to the power of 2x, 49 to the power of x, or 7x to 7x all squared, right? Depending on the context, sometimes you want to write it one way or the other if other things simplify with those things better. Now if I do this times this, now you add the exponents, you get 7 to the power of 0, which is actually just 1, right? And you do the middle terms, you also get a 7 to the power of 0, which is just going to be 1. And then 7 to the negative x times 7 to the negative x is 7 to the power of negative 2x. Okay, so these are going to be 1s in the middle. So we get 7 to the power of 2x plus 7 to the power of negative 2x plus 2, because that's 1 plus 1. Okay, so that's how we do that one. Let's move on to, let's see, some of these. Now, many of these are going to be very similar. Let's look at f first. F, well, very common when we have exponents, we want the same base. So we're going to rewrite that as 3 to the power of n plus 2 minus 3 squared. And then you can factor out, actually, well, let's write it like this. 3 squared times 3 to the power of n minus 3 squared. So we can factor out 3 squared, which is just 9, times 3 to the n minus 1. Okay? So often we want the same base in those things. Here, let's look at h. You get 3 to the power of n in each term, so you can factor out 3 to the power of n. And that's going to be left with 3 squared, because when you multiply those, you add the exponents. Plus 3 to the 1, plus just a 1. And actually, oops, let me just erase that. So this is just a number here. This is 9 plus 3 is 12 plus 1 is 13. So this all simplifies to 13 times 3 to the n. Okay, so that's how we do that one. And number 2, we have two different kinds of expressions. We have like b is a difference of squares. You can write that as 3 to the power of x squared minus 5 squared. So that's a difference of squares, so it factorizes to 3 to the x minus 5, 3 to the x plus 5. And then we got some trinomials, which we're going to see in the next example anyway. Firstly, okay, let's look at e. Okay, so we got 5 to the power of x here. We can rewrite this one as 5 to the x squared, and then we've got plus 4 times 5 to the x minus 12. That's just like a quadratic, right? If you like, we can do a substitution. Let y equals 5 to the x, so you're going to have y squared plus 4y minus 12. And then maybe we can factorize this quadratic, and that factorizes to y plus 6, y minus 2, right? Okay, but don't forget to actually write in what we're actually supposed to be using, x. So it's 5 to the x plus 6, 5 to the x minus 2. Okay, these are simplifying, but you probably want to factorize the numerator and denominator first. So let's just jump down to this one right here. If we factorize the numerator, we got 3 to the m, and then we got 3 to the 1 minus 3 to the power of negative 1 over 3 to the m times 1 plus 3. Now these we can definitely cancel, because 3 to the power of a number, you can never get 0, so we know we're not dividing by 0. So that cancels, and then we can work this out. This is like 3 minus 1/3 over 4. So I can multiply numerator and denominator by 3 and get 9 minus 1 over 12, which is 8 over 12, which is 2/3. Okay, so that's how all of these work. You can factor out an exponent there first. Okay, these are equations now, so this is not simplifying, this is solve, but we can simplify first in order to solve, right? So maybe we'll do number G. First of all, let's get everything on one side, and we got 7 to the power of x here. We can write this as 7 to the power of x squared. We bring this to this side. Minus 8 times 7 to the x plus 7 equals 0. We can do a y substitution. Let y equal 7 to the x, so we have y squared minus 8y plus 7 equals 0. So it's a quadratic that we can factorize. So that's y minus 1, y minus 7. Okay, that means y equals 1 or y equals 7, which means 7 to the x equals 1 or 7 to the x equals 7. These are easy to figure out. This is going to be 0, and this is going to be 1. So we have two answers, okay? For some of these questions, you might get something like, 7 to the x equals a negative number, and then there's no answer, so that will be impossible. That will come up in some of these examples.